those advantage in this PPT. Okay, I have mentioned all those advantage here. But now we will first see how is the construction of CMOS. So you see how CMOS is formed. Okay. So this is the diagram of CMOS, complementary MOSFET. Okay. So when we have studied N-channel MOSFET, so you know that there was a P substrate, right? In N-channel MOSFET, there was a P substrate. Okay. There was a P substrate, and in that P substrate, we have doped two regions with N-type semiconductor, highly doped. N plus indicates highly doped. So in that P-type substrate, there were two N regions formed, and it was the source and drain terminal. So this was the source terminal and this was the drain terminal. Now you just look at this portion. Just look at this portion. Okay. What you see? Is it your NMOS? Is it your NMOS? Does it look like NMOS? NMOS substrate is made up of P-type semiconductor. So this is your P-type semiconductor. Okay. So this is your substrate of that NMOS, and in that there are two N regions which are formed with N-type semiconductor doped heavily. And this is your substrate. You know, substrate and the source, they are connected together and we make it connected to ground potential. So this was the substrate. Sorry, this was the source and this was the substrate. Both are connected together and they are grounded. Okay. Then how you form a gate? Above there is space between these two N region. Just above that, over the SiO2 layer, over this SiO2 layer, this dashes indicate SiO2. So above that we used to deposit metal, and that is nothing but our gate. Okay. So if you look at this portion shown in yellow color, that is nothing but your NMOS, N-channel E-MOSFET. Okay, so this much portion is giving you N-channel E-MOSFET. Now what I said, that N-channel E-MOSFET and P-channel E-MOSFET, they are connected in series. Okay, here the circuit diagram is also shown and here the construction is also shown. Now if you want to make a P-channel E-MOSFET, then you know it will be opposite to that of the N-channel E-MOSFET. So here you have substrate made up of P region. There you want a substrate made up of N region. So there the substrate will be made up of N-type semiconductor, and in that N-type semiconductor we will be forming two two P region. Okay, two P regions, and our gate will be above the SiO2 layer. So here we have, this is the SiO2 layer, and above that we have a gate. Okay, this will be our gate terminal. This is the source and this is the drain, and this is substrate. So source and substrate are connected together and we will ground it. Okay, and this is your drain terminal. This is source terminal. This is substrate terminal or body terminal. Okay, now in CMOS, complementary MOS, you are using both PMOS as well as NMOS. So how this CMOS is formed together? Because you know, if you want to form PMOS, you need the substrate of N-type semiconductor. Is it clear? You learned the formation of NMOS. This is your NMOS. Okay. If you want to make PMOS, you need substrate of N-type semiconductor, and the source and drain of p-type semiconductor, right? So what is done here, in order to form this complete structure, in order to form this complete CMOS, complementary MOSFET, the substrate is made up of n-type semiconductor. The overall substrate is made up of n-type semiconductor. Now when substrate is n-type semiconductor, you can form easily PMOS in that. So what I will do, I will form two p regions in this substrate. Substrate is n-type, so we'll form two p region. So one is drain and another is source for PMOS. This is forming your PMOS. Okay, this is forming your PMOS, and this is your NMOS, right? Now combinedly, see how I will explain you. To form CMOS, we have a substrate made up of n-type semiconductor. So you have a substrate made up of, substrate is made up of, for CMOS, the substrate is made up of n-type substrate. So the substrate is n-type. Substrate is n-type. Okay. Now in this, as substrate is n-type, you can form here a PMOS. But to form NMOS, you need a p-type semiconductor substrate. So what we do, we form another p-type well. I call it as well. Okay, because if you want to make n-channel enhancement MOSFET, your substrate should be p-type. So what we will do, we will form a well of p-type semiconductor. Well, WELL. So you'll form the well of p-type semiconductor, and I will call it as p well, p-type well. Okay, because in this overall substrate I am creating another substrate, but I will call it as p well. This is my overall substrate. Now in this p-type well, I will form my n MOSFET, n channel e MOSFET. So now you know how to form it. So we have one n-type block here, another n-type block here, right? And above this we have SiO2 layer. SiO2 layer will be present throughout, okay? But to take the connection from here, we will etch it, and again we will form the SiO2 layer. But now for understanding, I am showing only above the gate. And this is SiO2 layer, and above SiO2 layer, a gate is deposited. Okay. So now a terminal which is taken out here, that is, which is this terminal? Yeah, please name this terminal. So this is your N block. This is also N block. So what I have constructed here is my EMOS. Okay, this is my EMOSFET, right? So this is the gate. Okay, this is the drain, and this is the source. Fine. Now you know you have to take one terminal from the body. So this terminal is taken out from body, then connect them with each other, okay, and connect the thing with to the ground. So this is my NMOS is ready. This NMOS is ready. So this portion actually is indicating N MOSFET. Now I want P MOSFET. So for P MOSFET, the base which is needed is N type. So it is already present there. So what I will do, I will form PMOS. Okay. So for the PMOS, this is the N substrate, and you have under that you have two P blocks, which are the drain and source of this. Okay. And again there is SiO2 layer and gate. In the similar way, there is SiO2 layer and gate. So this is the SiO2 layer present here, and above that there is gate. Okay, size is same. Okay, so even though it is looking something different, it is same. So now this is the drain of the next. This is the drain of PMOS. This is the source of PMOS. This is the gate of PMOS. Okay. When it's a PMOS, substrate is N type. I repeat again. The source and drain, they are made up of P type semiconductor. Okay. Now what is done, because this is a CMOS now. This complete structure is a CMOS. What is done in CMOS? The drain of this NMOS and drain of PMOS, they are connected together. Okay. So both the drains are connected together, and a terminal is taken out for output. So combining both the drain terminal, I have output terminal of CMOS. Okay. Similarly, to give input, both the uh, gates are connected together. So this is the gate of NMOS. This is the gate of PMOS, and both are connected together. Okay, to take a terminal for applying input. So by combining both the gates, input terminal is formed, and by combining both the drain, output terminal is formed. Okay. Now source. Okay, this is the gate of second, and this is the source. So this portion is nothing but your PMOS. This is your NMOS. This is the PMOS. Both are connected in series. So both gates are combined to take a terminal called as input terminal. Both drains are combined to take a terminal called as output terminal. Now where to apply supply voltage? So supply voltage is applied to the source of, see, sources are remaining here. So source of NMOS is grounded here. Source of NMOS is grounded, and because this is also the source, you know this is source and this is the substrate. So source and substrate here also, they are connected together, but now it is not connected to ground because this is your complete CMOS. So CMOS is having one input terminal, another output terminal. The source of CMOS is the source of your NMOS, and it is connected to the ground, and supply voltage VDD is connected to this one. Okay. So supply voltage VDD is applied. VDD is applied over here. Understood the construction? I have shown here, okay, as well as I have plotted it on whiteboard. So I'll repeat again. So you have to unmute and tell me. So first of all, CMOS is made up of PMOS and NMOS connected in series. NMOS, in the CMOS, the substrate is made up of N-type semiconductor. In that substrate, a P-type well is formed, and in this P-type well, NMOS is constructed. Similarly, on the substrate of N-type, PMOS is also constructed. The gate of both NMOS and PMOS are connected together to form input terminal. The drain of both are connected together to form the output terminal. Source of NMOS, I write here NMOS. Source of NMOS is connected to the ground potential and source of PMOS is connected to supply voltage. Okay, NMOS, PMOS connected in series. Understood? Understood? Is it clear? Construction of CMOS?
Yes, ma'am.
Yes or no?
Yes, ma'am.
Everybody. Construction is clear?
Yes, ma'am.
Yes, ma'am.
Good.
Yes,
Now
ma'am.
same thing we will look here in the diagram. Can you see this diagram? This is the construction I have explained it, you on whiteboard. Look at this diagram. So here whatever we have constructed is represented symbolically. So this is the circuit diagram. So you have one NMOS and you have one PMOS. So out of that, this is your NMOS. You have formed this NMOS here. So this is the symbol of NMOS. This is NMOS and this is PMOS. So this is your PMOS. Okay. So this is the symbol, you know how to show. These are the enhancement MOSFET. So you see the arrowhead is pointing outward for PMOS and arrowhead is pointing inward in NMOS. Fine. So both drain terminal, look here, both drain terminals are connected together. Both gate terminals are also connected together. So by connecting both gate terminals, we will give input. So that whatever you give here, that will go to both NMOS and PMOS. So source of PMOS is connected with VDD and source of NMOS is connected with ground, connected to ground. Understood the figure?
Yes, ma'am.
Now we will see how it work. Okay. Now understand that in order to work CMOS as an inverter. So yesterday we have studied MOSFET as a switch. So again I will try to draw. Look how I am drawing. Are you able to see this yellow color? Are
Yes,
you
ma'am.
able,
Yes, ma'am.
or it is looking very faint? Okay, anyway. So I have this MOSFET. I'm trying to show by showing the different color here. Okay, so this is your PMOS. I'll draw NMOS now. So this is your NMOS. What we have done, the gate of both. So this is the gate of first, this gate and this gate. Okay, they are connected together. And here we are going to apply input. Here we are going to apply input. Okay. Then what we are doing, this is PMOS. So we are applying VDD to PMOS. So here we are applying VDD, drain voltage. This terminal is grounded and both the drains are connected together. So both the drains are connected together, and at this terminal we will take output. Okay, so this is the circuit diagram for CMOS. Okay, this is the circuit diagram for CMOS. Okay, so this is your CMOS. This is construction and this is the circuit diagram. Now we will see how it is working. So now you should know how the PMOS and NMOS are operating. So I will write here for NMOS because you know very well NMOS. Now when NMOS connect, when NMOS start conducting, when NMOS start conducting, what should be the value of VGS? Whether it should be 0 or positive or negative?
Greater than VT.
Greater than VT, but it should be positive or negative?
Positive.
Positive.
Positive. Okay. So NMOS, if you want NMOS to be conducting, if you want NMOS to be conducting, what should be the value of VGS? And remember, VGS, that is gate voltage, is measured with respect to source. Okay. So I will say that if you want NMOS to conduct, if you want this NMOS to conduct, so VGS must be positive. That is, I will say gate terminal must be positive with respect to source. Okay, with respect to S. Gate must be positive with respect to source. Right. Now, opposite of that, if you want PMOS to conduct, what shall be the condition? When I say gate must be positive with respect to source, it means gate must be, in other words, I will say gate gate must be at higher potential than source. Understood? When I say gate VGS must be positive, okay, it means that gate must be positive with respect to source. It means that gate must be at higher potential. Positive means higher potential with respect to source. Now, when I talk about PMOS, tell me the condition. It is just opposite of this. If I want to make PMOS on, so what voltage shall I apply to the gate? Because in PMOS, this is N-type substrate. So minority carriers are whole. So gate has to attract the whole. So what shall the voltage to be applied on the gate?
Negative.
Negative voltage. Everybody? Negative voltage. Okay. So I'll say that for PMOS to conduct, these conditions are for conduction. These are the conditions for conduction. These are the condition for conduction, that if you want NMOS to conduct, so VGS must be positive. That is, gate must be positive with respect to source, or in other word, I will say gate must be at higher potential than the source. If you want PMOS to conduct, it means VGS must be negative. Okay, VGS must be negative, or I will say that gate shall be negative with respect to source. Or in other word, I will say that when I say gate must be negative, it means that gate must be at lower potential than, or with respect to, with respect to source. Okay, got it? The meaning of negative, positive.
Yes, ma'am.
Everybody?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay.
Yes, ma'am.
Now we will.
Yes, ma'am.
Okay, very good.
Yes, ma'am.
Now we will apply the input voltages. So we have, what we will do, we will set the value of VDD equal to 5 volt. Okay. What we have done, VDD is set to be 5 volt. VDD is equal to 5 volt. Now at the input, I have two levels. Okay. Input, I have two level. One is 5 volt, that is logic high. And another 0 volt, that is ground, which is logic low. Okay. So first of all, we will give here input as logic high, that is 5 volt. Okay. So let's make this as 5 volt. Now tell me the status of both NMOS and PMOS. This is your PMOS. Remember, this is PMOS. And this is your NMOS. When I have applied here 5 volt, okay, high voltage. So tell me, what is the status of gate with respect to source for this MOSFET, NMOS and PMOS? Which MOSFET can conduct? This is the gate. It is common for both. So gate is at 5 volt and source is 0 here. Look at NMOS. Can you see? Zoom your screen. Zoom your screen. Here input is 5 volt and the source is grounded for NMOS. Okay. But here input is 5 volt, that is gate is at positive, but source of this is at 5 volt. Both are same. Okay. Which MOSFET will conduct? Yes. Which MOSFET will conduct? Look at the condition. NMOS, gate must be positive with respect to source. Is it? Gate must be at higher potential as compared to source. Is it true in this case?
Yes.
Everybody.
Yes.
Yes.
So
Yes.
Yes, ma'am.
this condition is true, right? This condition is true. It means NMOS will start conducting. Look at PMOS. What is the condition? Gate must be at lower potential with respect to source. Is the gate at lower potential with respect to source? Source is at 5 and gate is at also 5. Is it at low potential? No, both are at
No.
equal potential. So potential difference is 0, right? So this PMOS will not conduct. Understood? Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes.
Very good. So in case 1 we have seen case 1. What was the case 1? NMOS is on, right? NMOS is on. And what about PMOS? PMOS is off, right? Correct?
Yes.
Because gate is at higher potential as compared to source. So NMOS will on, and here the source and the gate both are at same potential. So potential difference is 0. So it will remain off. Okay. So we have seen that when I have applied input logic 1, MOSFET PMOS was off and another MOSFET was on. Right? Then I will draw the equivalent circuit. Now next case. Let us take input as 0 volt. Let's say input is at logic low. Input is 0 volt. Now what is the status of NMOS and PMOS? Look at condition 1. Gate must be high at higher potential than source. Is it? Gate is at 0 volt. This is also at 0 volt. So will it turn on now?
No.
Everybody. Will NMOS
No.
turn on? No. What about PMOS? Gate is at 0 and source is at higher potential. Sorry. Yeah. Gate must be at lower potential. So gate is 0 and source is 5 volt. Gate is at lower potential as compared to source. So what about PMOS?
It will turn on.
PMOS will
Turn on.
conduct.
Very good. It will turn on. Are you getting everybody? Please tell me.
Yes, ma'am.
Yes, ma'am.
Okay. So I am right here. Second case. What happened in second case? Case 2. What happened to NMOS? NMOS is
Off.
off,
Off.
right? And PMOS
On.
On.
is on, right? Understood? Very clear, everybody. Now I will draw the equivalent circuit and we will see when in both cases. Okay. In case 1, but I have applied case 1 when what was the type of input here?
Logic high.
Logic high. So this is applicable when input to CMOS at logic 1, that is high. Okay. And case 2, when input to CMOS is at logic low. So 0 volt or ground. Got it? So here we use 5 volt and here we use 0. So you understood both these cases. Clear? Read it again. Read both the cases again. Now I am going to draw the equivalent circuit for case 1. Okay, so let's draw for case 1. Where is our NMOS? It is situated here and PMOS is situated above. Now, when in first case NMOS is on and PMOS is off. Okay, so I will show this with the help of switches. I'll try to show all these things with the help of switches. So case 1, here we have applied VDD. Then we were having PMOS. But in case 1 our PMOS was off, so I will show it by a open switch. Okay, I will show it by an open switch. And our NMOS was off, so I will show it by a closed switch. Okay, this is the closed switch and this is the open switch. Right? So here and PMOS is off, represented by open switch, and NMOS is on, represented by a closed switch. So this was the ground. Okay, and you know, this we have connected. This was our ground. Sorry, not ground, extremely sorry, it was our gate. Okay, so input was equal to 1. So I have represented here case 1. Now can anybody tell me what is the output voltage in case 1? What is the output voltage in case 1? Where we are taking output? Here. Okay, here we are taking output. It means I am taking output between these two terminals. Got it? I am taking output between these two terminals. This is our drain which is made common and this is the source which is at grounded. So from drain to ground. So what is output voltage here? VO equal to what? V in is 1 or 5 volt. V in equal to 5 volt, logic 1. So in that case, what will be output? Output is present between these two terminals. What is the voltage present? This is a closed switch. Okay, this is a short path. This is a closed switch. So what is the voltage across a shorted line? 0. Always remember, this is a short. Okay, this is a closed switch. So there is no resistance. Value of R is 0. So voltage across a short or this closed switch is equal to 0. So in case 1, I'll get when input equal to 1, or I'll say 5 volt, logic high, output equal to 0 volt. What happened? Inversion. Okay. What happened? Inversion. Now tell me the case 2. I will draw for case 2. Tell me what to draw. What to draw. Yes. Unmute yourself. This was your PMOS. This was your NMOS. I have represented this by open switch and this by closed switch. Now in second case, when you are applying input 0, so what this PMOS will be replaced by?
NMOS.
NMOS.
Close
PMOS will
switch.
be closed
Close.
switch. Correct. So in second case, PMOS will be represented by a closed switch and NMOS will be represented by a open switch, right? So here you have applied VDD. VDD is equal to 5 volt, right? So this is your logic high, remember. And PMOS will be represented by a closed switch. This is your PMOS. And NMOS will be represented by a open switch. This is NMOS. Okay, this is the ground. PMOS, NMOS, where you are giving input here. This is your common gate. So V in equal to 0 volt here, and you are taking output here. So you are taking output between these two terminals. This is VO. So how much will be VO now? So this is a closed switch. So you know across closed switch output equal to 0. So if you apply KVL in this loop, what you'll get? VDD is equal to voltage across PMOS plus voltage across NMOS, right? VDD is 5 volt. What is voltage across PMOS? Because it is closed switch, it will be 0 plus VNMOS. So what is voltage across NMOS? The whole voltage will be there across this open switch. So voltage across NMOS equal to 5 volt. Okay. So in case 2, when you have give case 2, what is output voltage?
5.
Are? So you have given input equal to 0 volt and you got output equal to 5 volt. So that is why it is called a CMOS inverter. When you give logic high, you get logic low at the output. When you apply logic low at the input, you get logic high at the output. Is it clear? Have you understood CMOS?
Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am.
Yes, ma'am.
Look,
Yes, ma'am.
look at the construction. It's a circuit diagram, then operation as a CMOS inverter. Okay, so I hope everybody has understood this.